So it's another day, and everything is fixed now and hopefully improved also. First thing here is that this piston is now fixed altogether with some Ergo 1925 glue, which is first very high strength and second a relatively low in Young's modulus, which means that actually pretty shock resistant, and so this is hopefully holding up good. Also glued all the shaft to the piston here. This gives quite some surface for the glue to hold on. All in all, the screw and the glued on piston on the shaft should be around 5 to 6 kilonewtons. So calculated by the surface area and the tensile strength of the glue. So this is one point. This will go back into the piggyback. And the other point is, what I didn't like from the design is that the piston on the main shaft, if it is going out in travel, it always rushes against this rubber bumper here, which doesn't feel too nice. And in the higher quality shocks, this is done by a negative metal spring.
And here you see the assembly of the RockShox Vivid, where the countermeasure spring or negative spring is working exactly for that reason, to counteract the forces of the main spring.
So what I did is basically I searched for a spring online which has the right measurements and the right strength, and glued it into it. Basically with the same glue, which is where it's hot glue in the middle here to make the glue not float into the hole. And then I solved the hot glue with a little bit of isopropylic alcohol, and this shaft is not touching anywhere. This should go in this side. And yes.
So I was just curious about the surface quality of the shaft, so I did some measurement on that. And yeah, I'm not an expert on that, what the numbers should be, but maybe you are, and please let us know below in the comments what you think.
I'm to put everything together again, and just by putting everything onto the shaft and everything in reverse. So this is the top side. I still have that here with a nut, and yeah, here are these washers and shimstacks. So this goes down, and there is two sides of this piston here. The elevated side is always tight and to the shims, so there's no oil flowing in the holes when the piston strikes back in this direction.
So you can actually dive pretty deep into that Shimstack assembly rabbit hole if you want to. There is a lot of information on the internet about these, and example given from the Qualpedia. This image shows the Shimstacks on the rebound and the compression side, which are symmetrical. And there's another image from DVO which shows that there is some more sophisticated Shimstack, which is, for example here the number 3, a crossover shim for easy transition from a low to mid-speed compression. And the others are more or less like smaller to bigger shims. And on the Olin's Knowledge Center there's also an illustration where you see that when the piston goes down, the rebound flow opens, and the other side is when the piston goes in, the compression flow opens. And from the suspension theory guide of RockShox, you see that there is also on the lower side a spring-loaded shim, which opens more easily in the compression stroke and then easily closes in the rebound stroke. So What really sums this up is that there is a lot of knowledge flowing into these Shimstacks from all these manufacturers, and I think Bolany did not really take care about this. They just really wanted to have some, find that as a parking lot adjustment, so they want the user to really have the feel, what I also first had, to have a lot of control about this damping adjustment via the external adjusters, so they made the Shimstacks really stiff, and for a good performance on trail they are actually a lot too stiff, so they're actually not really moving under pressure. So this is why there is such a very high feedback on these external adjusters, because if you really turn the rebound to the closed position, then the shock is not opening anymore. This is not what you want on a higher end shock. You want this Shimstack to be dialed in from the manufacturer as good as possible already in the high speed section, and that you can also like make a little bit more tweakage and adjustment from the external adjusters. I think a lot of adjustment could be done here to really improve the performance of that shock.
So I just thoroughly cleaned the parts with some brake parts cleaner and used this middle hard thread locker here. So it's the other day and the thread locker is hardened, and I adjust the Shimstack by not putting in 5 of the shims actually, and the Shimstack still is very hard. That's the top washer, and these shims are not in here, and instead of using this big washer I used a smaller one, which gives just a little bit of flex, because before it was completely sealed and hard as, yeah, there was no movement possible, and it's actually still pretty hard, but you see there is at least a little bit of flex now. So this is my first try, and I want to just see how it goes. I want to build the shock together now. The Shimstack down here is meant to be very much more flexible. There is increasing size of shims, and there is one smaller shim here, and then there is the final shim that blocks the openings, and this is really flexible. So this opens easily. This is the high-speed compression valve mechanism, and this is the high-speed rebound. And the high-speed rebound still is pretty firm, but a lot softer than it was originally. So yeah, that's the complete assembly now, and this is the opening for the low-speed rebound, which is not blocked by the spring. So it interferes just a little bit, but I think the opening is still not locked, because there is a little bit of width between the. So the amount of oil in the shock is pretty important, because if there is too much oil, the air volume here is too small. But I think you can also adjust the end progression of the end progression of the compression of the shock, but it will lead to very high pressures here. So I don't know what this container can hold with this retaining clip here before something shoots out or blows off, I don't know. So I want to put in the original amount of oil, and I think for the first approach I just pour in this amount of oil again, like the original oil. There is some debris in the bottom of the container, some smaller minor metal shavings, but this stood for some days now and everything is at the bottom. So What I'm gonna do is I will mark this container with a pen in some spots, so I can measure the amount with a scale, just with water later, and yeah, then I'll know what amount of oil is in the shock. And okay, this now is holding, and therefore the valve here is closed, it's not flowing over, so I have to open that. I think it's now slowly finding its way. Okay, this is the open position, obviously. So next, this would be walking in here. Now I see the oil flow in the piggyback. So now there is still air trapped here. This is why it's doing this sounds. So to get rid of the air, I have to put in the floating piston. Do this like this first. So maybe, yeah, like this. Okay. Then this can go in. Okay, so it's important to have this in first so that you can reduce down the volume of everything inside the shock. Get the retainer clip fixed. Have to put a little bit of pressure, just a little bit. And that's already 50 psi. It's actually not a little bit, like this maybe. And then I want to turn it over. And then there's clearly air here. Maybe I just do it like that. I think that's easier. I don't want to crush that adjustment knob. can feel that's really now smooth running against that spring. That's way better, I hope so. So, and now, therefore there's still oil in the shock and pressure in the piggyback. I think I just need to open this here just a little bit to release the air, because this is the highest point in the shock here. Ah, okay. Maybe that's been it. Just made. So I just let it sit for, I don't know, half an hour. And open it a couple of times, and every time some air came out until there was the movement completely smooth through the travel. And now I increased the pressure in the piggyback, and I just looked it up in the internet, and at least ChatGPT says it has to be around 10 bars or 150 psi. So I just did that, and now it's way harder to push down because there's a lot of pressure there, but it's running smooth all the way through the travel, and yeah, there is no strange sounds from it now. I cannot push like that with the camera on me. Yeah, I just want to try to give you a rough demonstration. So I can really push that down fast, and there's virtually no sound now. And by the air pressure alone, it moves up all the way against this new installed metal spring. So this is now the end position, and you see in the end it's running smooth against this metal spring, so I think it's pretty nice. So everything's built back together right now, and next would be to install the shock back into the frame, and I think you've seen that often enough, so I'm just gonna go ahead. And one little bit of information added: just glued all these shims to the spacer with a clamp and some super glue. Gonna show that in the picture, and because all the time the shims fell down, it was really annoying. So now this is one assembly, and yeah, just keeps the earrings from going out of the open eye of the shock. So this went in really easy now, and just wanted to show you that the open eye length of the shock is now 230, as it should be for the frame. So this is actually quite nice. And yes, the remaining travel of the shock is, I think, yeah, that decreased quite a bit. So I mean, I killed some of the travel actually, and but if you count all the rubber with, so it's still 60 something, so quite fitting to what it was and should be for the frame. So there we have it. I just installed the shock and did some testing here in my shop, just with sitting on the bike and give it a little bit of pressure, and yeah, the whole assembly blew off again. So the shock is now, I think, broken once and for all, and yeah, therefore it was broken in the beginning at the second ride with the same defect. I'm now gonna send it back, get my money back, and yeah, maybe I order a new one and put threadlocker on there right in the beginning, or I don't know. I think
all I can tell at this point is that I was pretty disappointed by that, and yeah, at least I got my money back. And guys, please tell me in the comments below if I should order a new one and try that with some threadlocker on there and try to really get a sophisticated Shimstack, or just leave it like that and move on to something new.